Hello, in this video we are discussing basic questions on statistics for the TCS exam. Now what is with statistics question is that when a student is preparing for, let's say, quantitative aptitude for any recruitment exam, he is moreover focused on studying topics like number system, speed, time, distance, time in work, and other topics. But when it comes to statistics, so statistics is one of those topics which a student is generally not preparing. Why? The reason is because it do not appear in all the exams. That is one of the reasons. And moreover, we think, okay, we know the basic things like with mean, median, and mode. So we know them. But what is specifically with regards to TCS exam is they are repeatedly asking questions on statistics. So definitely we would be working on the very basic elements of statistics in this video. Now, how this video is different from other videos you would see on the internet is the other videos what I have seen is they are just discussing the basic definitions of mean, median, and mode, moreover, and standard deviation, of course. And then they are discussing very basic questions. But if let's say a question is coming in the exam, so it is going a step ahead. It is a step beyond the basic definition. A kind of an analysis is going to be required in those questions. So moreover, we are going to work with the analyst and we would be discussing these definitions, but we'll be discussing questions where a little bit of analysis is required. Okay, so let's get started with the very basic things. Now, the first and the very basic idea with statistics is what is mean. Now, mean is simple. All of us know what is mean. Mean is simply the average. That is, let's say you have 5 terms and you need to find the average. So what will you do? You'll sum them up, divided by, let's say, the number of terms, and you're going to get the average. So mean is a very simple concept. All of us know it. Now, what is going to be critically important for us is how do we define median? Now, how do we define median? Let's take an example. Let's say I have these terms. Okay, let's say I have 5 terms like this and they were written like this. Now, what is the first step to calculate the median? The first step says arrange the term in ascending or a descending order. So as an arrangement, I'll arrange them like this. Now, this is an ascending order, I would say. Now, what is the basic definition of median? Arrange the term in ascending or descending order. Once you have done it, pick the middle term. That is going to be your median. So at the moment, what is my median? My median is, for the given set of 5 terms, my median is 13. Okay. Now, if let's say the number of terms were odd number of terms, I will have a specific middle term, as was the case with this. Like 5 terms, it was the third term once I have arranged them in an ascending or a descending order. But let's say I happen to include one more term over here. Let's say my order is fine. But what I have done now is I have included one more term. And now my number of terms is not odd, but you can say there are 6 terms. So my number of terms are even. Now, if I go with the definition, there is no specific middle term, or this is one way to say it, or you'll say there are 2 middle terms. You take the average of both, as in you do this, add them and divide it by 2, you'll get the average, which in this case is going to be 13.5, and this average is going to be my median. So I'll repeat the definition once again. If my number of terms are odd, I will have a specific middle term, that was my median. If my number of terms are even, I will have 2 middle terms. I'll take their average, as in this case it came out to be 13.5, and that value is going to be my median. I hope this is okay. Now we'll see how they're going to make questions on it. mean and median in a while, and let's include this as well. What is mode? So how do we define mode? Mode is again a very simple concept. It says the term which is coming the maximum number of times, or in other words you say the term which has the maximum frequency of occurrence, that is going to be mode. Okay, let's take an example. I have my terms looking like this. So what is my mode at the moment? Which is the term which is coming maximum number of times? Okay, let me make 4 threes over here. So which is the term which is coming maximum number of times? 3. So my mode is going to be 3. Now, please make sure mode is not the frequency. 3 was coming like 4 times, but I never said 4 is my frequency. That is my mode. The term was 3, which was coming maximum number of times, and thereby my mode is 3. Now, let's say I make a small change in it and I make them look like this. Now I have 4 twos as well. And beside I was having 4 threes from before. And if I ask you what is going to be my mode of this sequence of terms, you'll still say what is going to be my mode. Now, as per the definition, you can have more than one mode. So what is the term which is coming maximum number of times? It was 2 as well as 3 which was coming maximum number of times, and that maximum number of times was 4 over here. So my mode are both. My mode for this is going to be both. It's going to be both 2 and 3. I have 2 modes for the given set of terms. Okay, so now we know the basic, what is the mean? Mean is the average. And what do we know about median? You need to arrange the terms in an ascending or descending order and pick the middle term in when the terms are odd. And if the terms are even, you'll have 2 middle terms, take their average, and that is going to be your median. Now, but we need to work on more things now. Now, as a question, if let's say I put it like this, which is more? Is it the mean or the median? Okay, which is going to be more, as is it the mean or the median? Okay, I'll take 2 examples. Let's say I pick this example which says there is an ascending set of terms. There are 6 terms as you can see over here. 2 are x which are equal and 4 terms are identical which are y. So the set consists of 6 terms. Now for this set, if somebody asks which is more, mean or median? Now first of all, please have a look, what does it say? It is an ascending set. So what do we mean by ascending set? We mean the next term is either more than the previous term or at least should be equal. Now let's make the point clear. If I happen to write my terms like these, this is definitely an ascending set because the next term is more than the previous term. But if I happen to write my set like this as well, will it be an ascending set still? Yes, it is going to be an ascending set still because the next term is either more or equal to the previous term. So if this condition is also maintained, then the set is still an ascending set. Now keeping this in mind, one thing is there that for this set, y is definitely more than x. Now if y is more than x and we needed to compare mean and median, what is going to be my median over here? Okay, so I have 6 terms, I have 2 middle terms, both of them were y. Take their average and their median is going to be y again. So for this set, my median is y. Now, if we want to calculate the mean for this set, let's say if there were only y's over here, there were no x, but there were only y's, 4 y's, my average would have been y. But what did I do later on? I added 2x to those 4 y's. Now y was more and x is less. So you, in a way, you are adding terms which are of lesser magnitude. What will happen? The average is going to come down from y. And thereby, for this set, My median was y, but my is going to be more than the average. That is mean. Now, if I happen to look the other set, now this time they are saying this set happens to be descending, which means this means x is going to be more than y. Now, if I happen to look at this set, my median would still be y. You would agree with me? And if x's were not included, there were only 4 y's, my average would have been y. But when I increase to x to them, my average, because x is more than y, my average is going to be slightly more than y. It has to be more than y. For this set, you would say the average or the mean is more than the median. So at the moment, we could not establish something like which is going to be more, which is going to be less, whether it's a mean or a median. You would say in general, you cannot comment on whether which is more, mean or median. But yes, because in one of the in one of the cases, it was mean, and in other case, it was median. But yes, if you happen to be like, let's say my terms are in an arithmetic progression. Let's say my terms were looking like this, and they happen to be in an arithmetic progression. Now, if my terms were in an arithmetic progression, please try to find the median. Median is going to be the average. The median is going to be the average of these two. That is going to be 7. And if I needed to take the mean, look at this. These two sum up to 14. And there are two terms. So divided by 2, the average would have been 7. This again sums up to 14. Divided by 2, the average would be still 7. This again sums up to 14 divided by 2, the average will be still 7. For this, mean will be equal to median. So that is what they are saying. In general, you cannot say what is the relationship between mean or median, which is more, which is less. But if your terms are in an arithmetic progression, as was the case with these terms, mean is always equal to median. Okay, so keeping things in mind, now we try to analyze the definitions in terms of questions. Now, look at the first question. It says, which of the following could be the median of a set consisting of 6 different prime numbers? Now, if you read the question precisely, it says, which of the following could be. Now, why it is saying could be? Could be is like an open-ended question over here, because why it is a could be question? Because you don't know which terms are involved. It says, okay, they consist of prime numbers, but they are not revealing what exactly which prime numbers were used. So they are saying which could be the median. Okay. Now, okay, but one thing is there, they are talking about prime numbers. Now, keeping this thing in mind, if I want to work on this question, which is of course simple, but let's try to dissect it. Now, it says the numbers used here are prime numbers. So what do we know about prime numbers? Prime numbers are basically all the prime numbers are odd except the number 2, which is the only even prime number. Otherwise, all my prime numbers are odd numbers. So keeping this thing in mind, okay, I have a set which is like 6 numbers. So I would say, okay, my prime numbers would have been like this. I am just putting them in a kind of a notation. They were 6. And let's say I've arranged them in an ascending order, because ascending order would be essential when you want to find the median. So my median would be basically the average. My median has to be the average of these two terms, which are the middle terms over here. Now, if they, it's going to be the average. And what do I know? Prime numbers are always, what do I know? Prime numbers are always odd numbers. Prime numbers are always odd numbers, except for number 2. Now, if 2 was involved over here, and being an ascending set, 2 could have been only over here. Certainly 2 cannot be P3 or P4. Now, that means P3 or P4 are odd prime numbers. Now, if I add 2 odd numbers, what will I get? I'll get odd plus odd is going to be an even number. And if I divide this sum by 2, I'm dividing even number by 2. And what is basically an even number? Even number are always multiples of 2. And if you divide them by 2, 2 is going to get cancelled and the leftover has to be my integer. So if I want to calculate this median over here, my answer should come out as an integer. Now, if I keep this thing in mind, I can safely eliminate option C and D because they are fractions. My answer cannot be fraction. Now, if I want to work and eliminate A and B options, I would say, if I want to eliminate them as well, I would say, okay, let me go and take the minimum, the smallest prime numbers for these 6. The smallest prime numbers for these 6 in an ascending order would have looked like this, you would agree? And my median then would have been the average of these two, that would have been 6. So the minimum value of the median for this set can be 6. If the minimum is 6, certainly the answer cannot be 2 and 3. So the leftover, whatever it is, has to be my answer. Okay, now all the three together, mean, mode, median. Now, what does it talk about over here in this question? It says mode of 7 babies' height is 87. Average is 80. Median is 82. Lowest is 70. And you need to calculate the maximum value of the highest height among 7 if heights are integers. Okay. So let's stick to what is given. They talk about 7 people. 5, 6, and 7. Now, the lowest value is given as 70. Okay, if I'm going for an ascending order, this has to be my first term. And the average is 80. Now, what is the significance over here? Average of 7 terms is 80. So, if average of 7 terms is 80, you would agree if I wanted to find the sum would be 80 into 7. That has to be 560. Okay, so my sum has to be 560. Now, what else is given? Median is 82. 7 terms, the median has to be my fourth term. This value is 82. And the lowest is 70. Okay, I've already used it. What you need to do? You need to find the maximum value of the highest height. So you need to maximize this term. Now, if you want to maximize this term and you are keeping this constraint in mind that the sum has to be 560, you cannot go beyond it. Sum has to be 560, you cannot definitely go beyond it, and you need to maximize the last. So what you need to do is, if the sum is like 560 and you need to maximize it, so you are minimizing the others. Minimizing the others. Okay. One thing more, the mode is 87. When you say the mode is 87, what does it mean? 87 should be coming at least 2 times, because let's say other terms like 70 and 82, they are also coming once and they are not the mode. So 87 should be coming at least 2 times. At least 2 times would mean I can take this to be 87 and this to be 87. Now, at this point of time, you would have said, okay, can I not take this, the last term, to be 87? No, I would not take it, because if you solve it further, you would realize that the value of the last term can be more than 87. So I'll keep it as such and I'll try to maximize it. Okay. Now, since the mode is 87, it is coming 2 times. So definitely there cannot be, if you want to minimize this and this, you cannot take them to be 70. But since they are integers and they need to be minimized, I'm taking them to be 71 and 72. So my numbers look like this, and now they will sum up to 560, and that would give me effectively what is going to be coming out here. So if I add them, this is going to be like what? 210, 213, and this is going to be 80 into 3 is 240, and 249 and 256. 256 over here. So effectively, what am I going to get? I would be getting 259, 269, 469 if I add them. And now my answer towards the end has to be, sum has to be 560. So if I deduct 469 from 560, I'll get the maximum value. Maximum value for this term, the last term has to be 91. Okay, so next we are working on how to calculate the standard deviation. What is standard deviation? Now the very basic thing is, what is standard deviation? You say it is the measure of how much are the terms deviated from the mean. Okay, now let's have a look at the example that would make the things more clearer. Okay, so let's say my terms happen to be 2, 4, 6, 8 and 10. I have taken a very simple terms. They are also in an arithmetic progression. Okay, so how do we calculate standard deviation? The first step is calculate the mean. So the first step is calculate the mean. So the first step is calculate the mean. So if I would have calculated the mean, or I would have simply said this is an arithmetic progression, so mean is median. So my mean for this is 6. Now the second step is calculate deviation of each term from mean. Calculate deviation of each term from mean. Now, if I want to calculate the deviation of each term from mean, now first of all, what is deviation? Deviation means how much at what distance is the term located from the mean. So if I happen to want to calculate the deviation of 2 from 6, you would say it is deviated by 4 units. How much is the second term 4 deviated from mean? You would say it is deviated by 2 units. Coming to the mean itself, how is 6 deviated from mean? You would say there is no deviation, zero deviation. How is 8 deviated? Again, it is at a deviation of 2. And how is 10 deviated? It is at a deviation of 4. Third step is square the deviations. Square the deviations. So once you are squaring the deviation, the terms would be looking like 16, 4, 0, 4 and 16. Now the fourth step is take the average of the squares. Average of the squares. Now if you want to take the average of the squares, you would say, okay, my average over here for the fourth step is going to be, I add them, which is going to be 40, and I divide with the number of terms, that is 5. I get the average to be 8. The final step for calculating standard deviation is, standard deviation finally is square root of this average. So once you want to find the square root of the average, you would say my standard deviation is going to be square root of this 8. Now, I have elaborated this formula. Otherwise, you could have also written the formula like this. You would say standard deviation is basically whatever my term is deviated from the mean, and I need to take the square, sum them up, divided by the number of terms, and finally I take the square root. I could have also written it like this, but I have kept it simple. I am working with the very basic idea. Okay. Now, keeping this thing in mind, coming to the various properties of standard deviation, first of all, is this correct if I want to say that standard deviation is always greater than equal to 0? I can say it two ways. Towards the end, standard deviation is square root of some number. Now, square root of the average, what we are going to find. Now, the thing with the square root is it can only be 0 or positive. Square root cannot be negative. So the idea is, once again, standard deviation can be only 0 or positive. Now, next step, which is going to be very important, that we want to discuss the effect of doing various operations on standard deviation. Let's consider this. My terms were looking like this: 2, 4, 6, 8. I'm just working on that same set of terms, and I know the standard deviation came out to be square root of 8. I'll keep this thing in mind. Now, what next? I am adding 2 to each term. So if I'm adding, let's say, 2 to each term, my terms would be looking like this now. My terms would become like this. My mean would change. My new mean is going to be used, we'll say, is 8. But will my standard deviation change? If I want to go to the next step, which was calculate the deviation of each term from mean, from this 8, you will say the term is deviated by 4, then this is deviated by 2, and again this is not deviated, this is again deviated by 2 and 4, which is also equal to the deviations what I was getting with when my mean was 6, when I did not add plus 2 to each term. So since the deviation are same, towards the end my standard deviation will also remain same. So the effect of adding plus 2 or maybe some constant to each term is my standard deviation do not change. Same thing would have happened if I deducted a negative constant. My standard deviation would have remained same. So I can summarize it. If you add a positive constant to each term, standard deviation remains same. If you deduct a constant from each term, the standard deviation would remain same. Now what will happen if I multiply each term by 2? Now if I would multiply each term by 2, you would say my terms would be looking like this. Has my mean changed? Yes, my mean has changed. Now it has become 12. And did my deviation change? My deviation from the mean is 8, then 4, and then 0, then 4, and then 8. If I square them, my squares would look like this. And if I take the average would be, you would say, 160 by 5, which is 32. As a result, my standard deviation, which is going to be the square root of this average, has to be this, which would mean I can write it like this, and I can take this 4 outside. I'll say 2 into square root of 8. So what did I see? If I multiply each term by 2, my standard deviation also got multiplied by 2. So if you added a constant, nothing happens. If you deducted a constant from each term, nothing happens. If you multiply each term by 2 or some positive constant, standard deviation is also getting multiplied. Same thing will happen with division. If let's say you were dividing by some number k, standard deviation would also get divided by k. You basically write mod k. As in, if you're doing it with a negative as well, it is going to get divided by the magnitude. Okay. Now, keeping all this thing in mind, what we were discussing with regards to the theory, let's have a look at a very simple question. But yes, we need to analyze those things. It says if m is a negative integer and k is a positive integer, which of the following could be the standard deviation of this set? My set happens to be looking like having some negative terms, and m is also negative, that has been said, and then some 0 and some positive terms, and k is positive again. Now it says which of the following could be the standard deviation. Why could be? Because the terms are not exactly given. All the terms are not exactly given. But when I happen to look at my options, please have a look at it. It says minus 1.5. Can my standard deviation be negative? I know standard deviation can only be 0 or positive, because the last step in calculating standard deviation is taking the square root. So this cannot be my answer. Again, minus 2, this cannot be my answer. Now, when is standard deviation going to be 0? Standard deviation is going to be 0 if all the terms were same. There wasn't any deviation. So again, since the terms are not same, you will say it cannot be 0. So it cannot be all the 3. So what is my answer? It is none of 1, 2, and 3. So my answer has to be E option. So nothing much over there, just using the basic properties. We never knew what is m and what is k exactly, but we can find the answer for this question with the basic properties of standard deviation, that it cannot be negative and it can only be 0 if all the terms are same. I hope this is clear to us. Okay, then have a look at this question, which is basically again making use of how we are going to work with standard deviation when we are multiplying or dividing the terms. Okay, please have a look at it. It says set A consists of all even numbers from 2 and 100 inclusive, and set X is derived by reducing each term by 50. Reducing each term by 50 means the standard deviation is not going to change. So whatever the standard deviation for A is, same would be the standard deviation for X, because the standard deviation is not going to change. Now it says set Y is derived by multiplying each term by 1.5. So when you are multiplying by 1.5, the standard deviation will also get multiplied with 1.5. Okay, this we know. And the next is, if you happen to look at the next, it says set Z is derived by dividing each term by -4. So if you divide each term by -4, the standard deviation is also going to get divided by mod 4, irrespective of the sign. Which of the following represent the ranking of the three sets in descending order of standard deviation? So standard deviation would have been highest when it was getting multiplied with 1.5. So set Y, the standard deviation is going to be max. Then it is going to be set X, where the standard deviation do not change. So this was maximum. Then it was X. And then finally, it had to be the last one, which is Z, wherein standard deviation got divided by 4. Okay. This is, let's say, my standard deviation original. This was 1.5 times into standard deviation, which was Y. And this was standard deviation divided by 4. Okay, look at this question. It says set A, B, C are shown below. If number 100 is included in each of these sets, which of the following represents the correct ordering of the sets in terms of absolute increase in their standard deviation from largest to smallest? Please read the questions correctly. Which of the following represent the correct ordering of the set in terms of absolute increase? So you want to mention in which of the set there is more increase compared to what it was before if you added 100. Okay, so please have a look at the first set over here. If I happen to just happen to look at the terms, my mean was 70. And how much are my terms deviated from mean? I can see it like this. Now, if I happen to insert 100 over here, 100 would be inserted over here. Okay. So it is like somewhat mean is 70 and there is a new term which is like little deviated, and that is 100. Now we need to compare the other terms also, and we are not going to calculate anything for standard deviation. Calculations are not required, only analysis is going to be required. Okay, please have a look at the next set. What is the mean at the moment? The mean was 0. And where is the new term? The new term would be coming after a distance from the last term. 100 is going to be at a distance. Over here with the last term, you see the mean was 40 and again 100 is over here at a distance. But where is my 100 at the maximum distance? The maximum distance was with B, where the mean was 100, 0, and it was at a long distance. Here it was at, you can say, still the distance is more from 40 to 100, and it was the smallest over here with A set. So you want to say where there was the maximum increase? The maximum increase was with B, followed by C, and finally followed by A. At this point of time, please try to realize whatever the kind of question on standard deviation is, they're just making use of the basic theory and the basic analysis, but no calculations are going to be involved if it is a good question. Okay, so towards the end, let me review the things back again. My intention of working on with the definitions of mean, mode, and median were this, that okay, we know the definitions, but we need to analyze them in terms with regards to questions. Now coming back to standard deviation, my emphasis was please don't only work at the with the formula, but try to analyze the formula, because moreover the questions are not going to demand that we want to, they would not demand that you are going to calculate the exact standard deviation. Moreover, they would be asking you to compare the two standard deviation, which can be done based on the very basic theory and analysis of the formula. So that's all from my end. Statistics which do come on TCS is very simple. Please keep the elementary things in mind and things would be very simple. That's all.